Earth Systems 3209, Unit 4, The Forces Within Earth. Reference for this unit can be seen in Chapters 4, 15, 16, and 19, and also in Appendix A and B of the Curriculum Guide. Unit 4, Topic 4.4. We'll look at the two different earthquake scales. We will focus on comparing the two scales that can be used to measure earthquake intensity and magnitude. We will also focus on identifying, in relation to the Richter scale, how wave amplitude and energy release changes for every increment of 1 on the Richter scale. When we look at the two earthquake scales, an earthquake is the vibration of the earth caused by rapid release of energy. Slippage along pre-existing faults and sudden movement within subduction zones are commonly the cause of earthquakes. Seismologists use two scales when classifying earthquakes. First being modified Mercalli scale, and the second being the Richter scale. Information on these two scales can be found in the textbook on pages 451 to 455. Let's first investigate the Mercalli scale. The Mercalli scale measures the intensity of an earthquake on a Roman numeral 12 point scale. In 1902, Mercalli developed a fairly reliable intensity scale which assesses the damage to various types of structures at specific locations. Note that the earthquake intensity is determined by several factors, including, number 1, the strength of the earthquake, the distance from the epicenter, the nature of surface materials, and the building design that would be affected by the earthquake. The Mercalli scale does not give a true indication of the actual strength of an earthquake because the amount of damage done to different places will largely depend on the type of material used and the degree of construction of buildings and structures. To the right, we can see a representation of the modified Mercalli scale. The Richter scale, in comparison, measures the magnitude of an earthquake on a 10-point scale. And in 1935, Charles Richter introduced the concept of earthquake magnitude. Richter magnitude is determined by measuring the largest amplitude, that is wave height, recorded on a seismogram. And the largest recorded earthquake at that time had a Richter magnitude of approximately 8.6 on the Richter scale. If we look to the right, we can see a chart that represents the Richter magnitude scale. When we compare the Richter scale and the Mercalli scale, we can see that the Richter scale is a scale based on magnitude. And magnitude can be referred to as energy released and also wave amplitude. It uses instruments to record the magnitude called seismographs. The Richter scale also uses the Arabic values, and it's an open-ended scale. That is, it starts off at 0 and it has no open or top end to the actual numbering. In comparison, the modified Mercalli scale is a scale based on intensity. And intensity measures the amount of destruction at one given area. It uses human observations to base its intensity. It's a Roman numeral scale, and it's a closed-end scale. It basically is a scale that goes from Roman numeral 1 to Roman numeral 12. The Richter scale, when we look at Richter magnitude, it can be expressed in two ways. Richter magnitude could be expressed according to wave amplitude, and wave amplitude increases tenfold. That is 10 times more amplitude for every increment of 1 on the Richter scale. The Richter magnitude can also be looked at according to energy released. and the energy released increases 30-fold, which is 30 times more energy released with each increment of 1 on the Richter magnitude scale. While it is correct to say that for every increase of 1 of Richter magnitude, there is a 10-fold increase in amplitude of the wave, it is incorrect to say that each increase of 1 in Richter magnitude represents a 10-fold increase in the size of the earthquake. A better measure of the size of an earthquake is the amount of energy released by the earthquake. When we compare the two scales that represent the Richter scale, we can look at the wave amplitude that is released and measures the magnitude of the earthquake according to the Richter scale. When we look at wave amplitude, the amplitude increases 10-fold with each increase in Richter magnitude. Thus, a magnitude 7 earthquake releases 10 times more amplitude than a magnitude 6 earthquake. And a magnitude 8 earthquake measures 10 times 10, which is 10 times greater, more amplitude than a magnitude 6 earthquake. And this process goes on and on. So when we look at every increment of 1 on the Richter scale, the amplitude increases 10 times. So if we go up 2 increments on the Richter scale, the amplitude goes up 10 times 10, which is 100 times greater. When we look at the energy released according to the Richter scale, the energy released increases 30-fold, which is an increase in Richter magnitude. So therefore, when we look at each increase in 1 in Richter magnitude, it'll represent a 30-fold increase in the amount of energy released from the earthquake. Thus, a magnitude of 7 releases 30 times more energy than a magnitude of 6 earthquake. And a magnitude of 8 earthquake releases 30 times 30, which is 900 times more energy than a magnitude 6 earthquake. And this pattern goes on and on. So when we look at the energy released according to the Richter scale, with every increment of 1 on the Richter scale, the amount of energy released is 30 times greater. So if we go up 2 increments on the Richter scale, the amount of energy released would be 30 times 30, which is 900 times more energy. Let's look at the Richter scale and have a look at the 2 ways the Richter scale can be represented. One is by wave amplitude, which increases 10 times for every increment of 1. And the second is energy released, which increases 30 times for every increment of 1. So if we look at several different magnitudes of earthquakes, the energy released is represented as follows. If we look at the wave amplitude, which increases 10 times for every increment of 1, if we go from a magnitude measuring 3 to a magnitude measuring 4, that would increase 10 times. An earthquake measuring 4 compared to one measuring 5, again, would increase 10 times, and so on. 5 to 6, 10 times, 6 to 7, another 10 times, and so on. So if we look at an earthquake measuring 3 on the Richter scale, compared to one measuring 6 on the Richter scale, we would notice that the wave amplitude will increase 10 times, then another 10 times, and a third 10 times. So we would see that 10 times 10 times 10 would equal 1,000. So an earthquake measuring 3 compared to one measuring 6 on the Richter scale would be 1,000 times more wave amplitude. In comparison, if we go over to the right side and we look at the amount of energy released, the energy released increases 30-fold, which is 30 times greater. So an earthquake measuring 3 on the Richter scale compared to one measuring 4 would be 30 times more energy released. 4 compared to 5 would be 30 times more energy released. And 5 compared to 6, 30 times more energy released. And 6 compared to 7, 30 times more energy released, and so on. So again, if we compare an earthquake measuring 3 to one measuring 6 on the Richter scale, we would notice that we'd have 3 increments of 30. So an earthquake measuring 6 on the Richter scale compared to one measuring 3 would be 30 times, 30 times, 30 times more stronger. So 30 times 30 would be 900, and 30 times 900 would be 27,000. So an earthquake measuring 6 on the Richter scale compared to one measuring 3 on the Richter scale would be 27,000 times more energy released. Let's look at a sample problem. The sample problem reads, in terms of magnitude, an earthquake measuring 7.2 on the Richter scale has a wave amplitude of how many times, and that's the key right here, how many times greater than an earthquake measuring 4.2. So below we see the amplitudes arranged. 4.2, okay, 5.2, 6.2, and 7.2. Each increase in Richter wave amplitude would be 10 times greater. So if we start off with the first earthquake measuring 4.2, 5.2 would be 10 times greater, 6.2 would be another 10 times greater, and 7.2 another 10 times greater. So we see that an earthquake measuring 4.2 on the Richter scale compared to one measuring 7.2 on the Richter scale would increase 10 times with 3 increments. And that would equal 1,000 times. So an earthquake measuring 7.2 on the Richter scale would be 1,000 times greater than one measuring 4.2 on the Richter scale. Let's look at some examples. Example number 1 reads, how many times more energy is released in a 6.5 Richter magnitude earthquake than one with a Richter magnitude of 4.5. So again, if we look at our Richter magnitude here, we're looking for energy released. The amount of energy released is 30 times greater for every increase in Richter magnitude. So if we're looking at going from 4.5 to 6.5, we're looking at increasing at least 2 complete amplitudes. So for each increase, we see an increase in energy released of 30 times. So our answer in this case will be 900. An earthquake measuring 4.5 on the Richter scale would be 900 times greater than one measuring 6.5 on the Richter scale. Question number 2 reads, which of the following measures an earthquake's intensity based on the observed effects on people and structures? So in this question here, the key point will be intensity. And intensity is measured by the modified Mercalli scale. So our answer to this question would be B, modified Mercalli. Example number 2. Example number 2 reads, an earthquake with a magnitude of 7.2 did not cause any buildings to collapse. How would this earthquake be rated on the Richter and the Mercalli scales? If we look at the Richter scale, we look at a magnitude of 7.2. 7.2 on the Richter scale would represent a high magnitude. So therefore, according to the Richter scale, an earthquake would be rated high if it had a magnitude of 7.2. But the earthquake did not collapse any buildings. And according to Mercalli's scale is based on intensity, which looks at destruction. So if no buildings were to collapse, it would be rated fairly low on the earthquake scale. So according to Richter, it would be high, and according to Mercalli, it would be low. Therefore, the answer to this question would be B. Richter would rate the earthquake as high, 7.2 on the Richter scale, and Mercalli would rate it as low, where no destruction of buildings or no buildings collapsed, therefore below. So the answer to this question would be B. Example number 3. Based on the information below, which earthquake showed the greatest amplitude and by how much? It says here, an earthquake in Japan registered 7.5 on the Richter scale, and another earthquake in Mexico registered 6.5 on the Richter scale. So if we look at the amount of amplitude, amplitude increases by 10 times with every Richter amplitude that increases on the Richter scale. So in this case, the earthquake in Japan registered 7.5 on the Richter scale, whereas the one in Mexico measured 6.5 on the Richter scale. So therefore, it would increase in amplitude by 10 times, and Japan would have the higher amplitude earthquake. So your answer to this question will be A. The Japan earthquake would be larger in wave amplitude by 10 times. Your turn. Take time and complete the following question. You can record or you can pause your recording now to prepare your answer. The question reads, with every increasing number on the Richter scale, which describes the correct factor by which the energy released and the amplitude increases for a given earthquake? So when we look at energy released, the energy released according to Richter magnitude would be 30 times for every increment of 1 on the Richter scale. And wave amplitude would increase 10 times for every increment of 1 on the Richter scale. So the answer to this question would be C. Energy released increases 30 times, and the wave amplitude increases 10 times. So the answer to this question will be C. Summary of the points covered in this presentation. Earthquakes are measured using 2 scales, these being the Mercalli scale, which measures the intensity, and the Richter scale, which measures magnitude. Earthquake magnitude is measured in 2 ways. One way we can measure magnitude is looking at wave amplitude, and wave amplitude increases tenfold. That is 10 times with every increment of 1 on the Richter scale. Another way we can measure magnitude is by looking at the amount of energy released by earthquakes. So energy released increases 30 times, or 30-fold, with every increment of 1 on the Richter scale. So these are the main points that were covered in this presentation.